Hello students, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So today we will be discussing unit number 5, lecture number 3, high performance, high strength concrete. So this is also very important, because nowadays for important work like that, like multi-story building, high-rise buildings or long span bridge, it is necessary to reduce the cross section and get the better performance. So considering all these things, now a demand of high strength concrete has increased, and we will be discussing this, what is high strength concrete and how can we design. So lecture number 3 we will be discussing the generals, and in lecture number 4 we will do the illustrated design of high strength concrete. So high strength concrete, how can you define? So high strength concrete is the concrete that has characteristic compressive strength of 65 Newton per mm square or more. So this is the definition given in IS 452,000, amended in 2013. So they have divided in 3 groups. One is ordinary concrete, whose strength is M10 to M20. Then we have a standard concrete, their value ranges from M25 to M60 and M65 to M100. So even it is going more than M100, then you can say it is a ultra high strength concrete. So high strength concrete means which characteristic strength at the age of 28 days, if it is tested on 150 mm size cube, considering the Platen effect also, their strength should be between 65 to 100 Newton per mm square. So this is the specification of IS 456. If you refer other countries, they define high strength concrete in different way. Okay. So they depends on the country, their codal provision differs, but we say if our strength of concrete is greater than means characteristic strength is between 65 to 100, we can say it is a high strength concrete. So what is the use, what are the applications? So generally we use in high rise structures, particularly columns of lower floors, because load coming from the top, bottom their load will be more. So lower sides of the column we can go for high strength concrete. If you are going high strength concrete, certainly their cross sectional area will reduce. Similarly, we can use for shear walls, foundations. Why shear walls? Because you can use the thinner section, okay. And foundations also, if the depth of the foundation is coming more, particularly for high rise building, then in that case we can go for high strength concrete. Similarly, we have a long span bridge, so their dead load is more. So in that case we can consider high strength concrete. Even for nuclear power project, now suppose you want to make the dome, okay. So that dome can be done with pre-stressed concrete, and there you can use the high strength concrete. So these are the things which is important for the application of high strength concrete. And what is the composition of high strength concrete? So first requirement is low water cementitious material ratio, as high binder content for high quantity of paste is required. And similarly for this requirement, you need a water cement ratio like this. So so low water cement ratio means, if you see the Abraham's this curve, so this is a water cement ratio and this is the strength. So if you want to produce a high strength concrete, their water cement ratio should be lower side. So that is one of the requirement, and we need a more quantity of fine mineral admixtures. Okay. Like what are the fine mineral admixtures? Like we have silica fume, fly ash, metakaolin and so on. So, these are the GGBF. So, all these things should be more in quantity, and we have to reduce the maximum size of the aggregate, so that we can achieve a better density, better compaction. So, for better compaction, good packing is required. So, we will reduce the size of the concrete. So, generally for high strength concrete, we never go the aggregate size more than 20 mm. So, better if you want to produce higher grade of concrete M80 and above. So, in that case you need a size of maximum size of aggregate around 12.5 mm and downside. So, because you need a reduced water cement ratio. So, for that purpose what we have to do? We have to increase the dosage of super plasticizer, so that we can reduce the water demand, because as the water demand will increase, amount of cementitious material will increase. So, water content for that purpose we are using the super plasticizer. Okay. So, what is the microstructure of high strength concrete? If you consider micro strength concrete, so they should be more homogeneous. So, throughout the body we should have a similar type of material. So, for that purpose we have reduced the maximum size of the aggregate, and another thing, we need a very thin interfacial transition zone, ITZ. So, ITZ is very important for the getting the better strength of the concrete. So, if you are say we have an aggregate like this, okay, so there will be layer of water cement here. Okay. So, here will be the cement paste, we have cement paste, we have a cement paste. Okay. Cement paste is there. Okay. And if it is a coarse aggregate, and in cement paste we have mortar also. Okay. So, how we are getting the cement paste? Water plus cement. If you mix, this is going to give you the paste. If you increase the, you have a paste plus sand, this is going to give you the mortar. Okay. So, mortar, so almost if you are considering the ITZ for the mortar, so their thickness will be almost nil, negligible thickness. But if you consider the coarse aggregate also, if let us say this is the coarse aggregate, so this zone will be also very thin, because this will have more water cement ratio, at that interface. So, we have to consider the interface of the concrete, interface of the aggregate and paste. So, those will create the more porous structure here, as well as water cement ratio is more. So, this is the weakest point, is the weakest zone in concrete. Okay. So, our purpose is to reduce the interfacial transition zone, so that we can get the high strength concrete. So, we should have low porosity, not more than 1 to 3%, lower percentage of capillary porosity. So, generally permeability coefficient should be less than 10 to power minus 11 centimeter square per second. Similarly, we should have lower water absorption. We should have low diffusivity of carbon dioxide and chloride. So, if and that value should not be more than 10 to power minus 9 centimeter square per second, because if there will be ingress diffusion of carbon dioxide and chloride, so that will create the durability problem. So, carbon dioxide, what it is going to do? Carbon dioxide is going to reduce the pH of the concrete. So, your steel will be no more in passive condition if carbonation is taking place. So, if diffusivity is less, then what will happen? The rate of diffusion will be very, very slow. Similarly, with chloride also. Chloride, if our porosity is very small, so in that case also ingress of chloride will be less, and due to that there will be no corrosion in the reinforcement. And similarly, if water absorption is less, then ingress of air as well as water moisture will be less. So, corrosion will not take place. So, corrosion cell will not develop on the reinforcement. So, that is very, very important for the high strength concrete. So, this is the microstructure of high strength concrete. So, now you see the cementitious material. What are the cementitious material we need? So, proper selection of type of cement is also important, because amount of cement is more. So, heat of hydration will be there. So, heat of hydration is there, there will be problem of autogenous shrinkage also. So, if all this thing is there, so we have to select proper type of cement which will give you less heat of hydration, particularly the cement which have low percentage of C3A is better, and high strength cement is also better. So, you can use 43 grade or 53 grade or even more for producing the better high strength concrete. So, what are the mineral admixtures? So, mineral admixture is important, because water cementitious material we have to consider. So, for that sake, if you consider only cement, then percentage will be more, and there is a restriction of amount of cement due to the consideration of heat of hydration. So, what IS 456 say, you should not use more than 450 kg per meter cube of cement. So, in that case we can use for mineral admixture. So, what are the mineral admixture you can recommend, like fly ash, silica fume, ground granulated blast furnace slag, metaculene. So, either you can use as a single unit or with combination of this. So, these are the requirement of cementitious material. Then we have coarse aggregate. So, what are the coarse aggregate? So, coarse aggregate means it should have a strong, sufficiently sound, free of fissures, weak planes, clean and free from surface coating, and that should be conforming to IS 383. So, requirement of IS 383 must satisfy, and you must see that it should be very clean, means you should not have weathered rock in that one, or their surface should be clean. There should not be a silt or clay coating on that. Okay. So, that must be clean. Okay. Then crushing stone aggregate, crushed stone aggregate we have to use, okay, instead of natural aggregate, because we get better interlocking. Okay. And impact crushing value should not be more than 22%. 22% say crushing stone value, impact value and crushing value should be less than 22%. And similarly, combined flakiness and elongation index should not be more than 30%. So, this is the requirement of coarse aggregate. So, selection of coarse aggregate is important, and generally size I had discussed, their size should not be bigger. Generally, for better strength you can use 15 mm and downside, and not more than 20 mm at any case. So, once you want to produce the even greater than 80 megapascal concrete, then we have to use 12.5 mm and downside coarse aggregate. Then we have fine aggregate. So, fine aggregate generally we should prefer zone 1 and zone 2, because they have little coarser in size, but not zone 4. Zone 3 also, if you are not able to get, you can go for zone 3, but already we know lots of cementitious material is there. So, coarse size of zone 1 and zone 2 will be okay for producing the high strength concrete. What are the chemical admixtures? So, chemical admixture is very important to reduce the water demand. Okay. So, and to get the better workability. So, high strength concrete mix usually have a lower water cementitious material ratio, cementitious material. So, cementitious material consists of cement plus other mineral admixtures. Okay. These low water cement ratios are generally only attainable with high range water reducing admixture. So, you have to reach HRWRA. Generally polycarboxylate ether based, if you are using admixture, then it will be better for high performance concrete. So, superplasticizers which reduces water content by at least 30% or above. So, we have to check, you take a guarantee from the manufacturer. So, how much percentage of water it is able to reduce. So, different brand will give you different brand name, commercial name. So, that you have to ask. So, there are different ranges. So, that supplier will tell you, and then you have to go for the trial for understanding this things. Then maximum size of aggregate generally restricted to 20 mm, but if you want to produce M80 and above grade concrete, so in that case maximum nominal size is restricted to 10 mm to 12.5 mm. So, M80 and above aggregate you want, strength you want, then you have to use 10 mm to 12.5 mm maximum size of aggregate. Okay, maximum size of aggregate. So, you have to get 12.5 and also. So, selection of water content and admixture content if you want. So, for if you are using a 10 mm size, then water requirement is 200 kg, and that is without considering the chemical admixtures, and this is for a slump value of 50 mm. And if you are using 12.5, then 195 kg. If you are using 20 kg, then you have to use 186 kg of water per meter cube. Okay. And we have to use generally polycarboxylate ether based superplasticizer, which will be able to reduce the water demand by about 30%. Okay. So, that also you can consider after the trial. Okay. Then we have selection of water cementitious material. So, for that what you have to do for selecting the water cementitious material, if you see this table that is recommended in IS 10262 2019. So, this table has been taken from there. So, if your target strength is 70, then depends of the size of aggregate. Say you are using 10 mm size, 12.5 mm maximum size, nominal size of your 20 mm maximum nominal size of the aggregate. So, depends on that strength. So, this is nothing but mean target strength. This is your mean target strength. Okay. So, depends on that. Suppose ours is 20 mm and I need a strength of 90. So, if you are using a strength of 90, so you have to use a water cement ratio of 0.26. We have to use a water cementitious material. So, water divided by cementitious material ratio should be that we have to obtain from this table. So, this is the one of the things given. Otherwise, you can use this also. You can try with the chart given in IS code. So, with the help of that also you can calculate the what should be the water cement ratio. So, 3 types of curve is given here like this, like this, like this. So, this is for 53, this is for 53 grade curve 3, this is a curve number 2 and this is curve number 1. So, curve number 1 is for 33 grade cement, curve number 2 is for 43 grade or plus if you are using the mineral admixture PPC, and if you are using 53 grade then you can use the curve number 3. Okay. So, recommended dosage of mineral admixture material for high strength concrete. So, how much that has been given this guidelines, so that based on that you can use that fly ash 15 to 30% you can use, GGBF you can use 25 to 50%, metakaolin you can use 5 to 15%, silica fume you can use in the range of 5 to 10%. So, this is the recommendations of IS 1026 2019. Similarly, estimation of coarse aggregate proportion. Okay. So, depends on the zone. So, generally we can use zone 1, 2 or 3, 4 zone has been discarded here, and this is also has been taken from this table has been taken from IS 1026. Okay. If you see here types of the nominal 10 mm, 12.5 mm and 20 mm downside aggregate, say you are using a zone, depends on the zone 2 sand. Let us say you are using a zone 2 sand and let us say our maximum size of aggregate is like this. So, you have to use this value, and this value is for water cementitious material ratio of 0.30. Okay. So, these are the requirement of estimating the coarse aggregate from the fine aggregate. So, all these things you have to understood. So, then how you can get the estimation of fine and coarse aggregate content? So, once you know the what was the first step, we have got the water cement based on the water cement ratio, based on the water requirement, we have calculated the amount of cement. Okay. So, cement plus cementitious material, that we have already achieved. So, based on that now we want to find out what should be the fine and coarse aggregate content. So, for that we have already calculated weight of cement, weight of mineral admixture, and air content also there is a table. So, from that table suppose you are using a 20 mm size maximum size of aggregate. So, air content is not more than that is varying between up to 1% you can say. Okay. So, that table, from table you can select the percentage of air content in the concrete, air entertained concrete. So, for 20 mm downside value is given, 12.5 mm and downside value is given, and 10 mm downside value is given. So, that we can calculate the that also. So, volume of air is also known. Then we know mineral admixture also, you can find out what is the volume of weight of fly ash and what is the silica fume and others like metakaolin others. So, that weight you can calculate. So, then you have calculated volume of air, weight of water content is also known. Okay. So, now we have to convert this into volume. because we have calculated the specific gravity by experimentation. So, a specific gravity of cement is known, a specific gravity of mineral is known, a specific gravity of water is known, a specific gravity of admixture is known, chemical admixture. So, all this thing is known. So, based on that you can calculate the volume of other material. So, how to get? So, suppose you want volume of cement. Okay. Suppose you want volume of cement. So, what we have to give? Weight of cement divided by a specific gravity divided by 1000. So, this will give you the volume per meter cube. Per meter cube, that is going to give you the volume per meter cube. Similarly, I want volume of fly ash. So, similarly, if you want volume of fly ash, how to get? That is weight of fly ash divided by a specific gravity of fly ash divided by 1000. Okay, that will give you per meter cube. Similarly, want volume of silica fume. Let us say we have a silica fume. So, once again weight of silica fume divided by a specific gravity of silica fume divided by 1000. So, all these quantities are known. So, then what we have to do? So, what is the total weight of volume of aggregate? So, that you can calculate. Total volume is 1 and then volume of air minus volume of cement, volume of water. Okay. So, all these things is just and volume of minus volume of admixture. So, if you minus this, that is going to give you the total volume of coarse aggregate plus fine aggregate. So, once you know the total volume of fine aggregate and coarse aggregate, and here we know what should be the volume of coarse aggregate per unit volume of total aggregate. So, just you multiply by this quantity, you can get the volume of coarse aggregate. Similarly, in total aggregate, you multiply 1 minus 0.66. So, that is going to give the volume of fine aggregate. Okay. So, once you know the fine aggregate volume and coarse aggregate, then what you have to do? You are supposed to multiply. Okay. So, you have to multiply. I want weight of say coarse aggregate. So, that will be given by volume of coarse aggregate into a specific gravity into 1000, that is give in kg. Similarly, we want to find volume of fine aggregate. There also we have to take the volume of fine aggregate, multiply by a specific gravity, multiply by 1000, that is going to give you the ratio. So, now we have got the weight of all the material like cement, coarse aggregate, fine aggregate, admixtures, okay, fine and all these ingredients we got the value. So, but that aggregate is for surface dry condition, but in actual condition you will get some water absorption will be there in coarse aggregate and fine aggregate, and similarly you may have some moisture already present in the aggregate. So, that adjustment also you are supposed to do. So, after doing the adjustment trial run, you can do the mixed design. Okay. So, we have learned this thing in brief, how to what is high strength concrete and how to achieve high strength concrete. So, we have discussed procedure according to the IS code 1026 2019. 19. Okay. Thank you.